Now what we've got is we have another infinite sheet of charge, which is in essence connected to this. So what I want you to think about is that you have a wire that's coming out at you, it's curving down, and then here it goes away. So each one of these is going to be a coil. So there's a coil, there's a coil, there's a coil, and there's another coil of wire. And this will be, in essence, think of it sort of as empty space. There's nothing going to be in there. Maybe some air that we don't want to think about necessarily in terms of vacuum. But here's a coil, here's a coil, here's a coil. And what we've done is we've taken these loops of wires and we've just done a cross section. We just cut them just as such. And so if this is going to be going out at you, then down here, it's going to be going away from you. Right? It's going to be going away from you. And what we're really describing here is we're describing a solenoid. And we've already found that the magnetic field due to this top one is mu naught Ni upon 2. Likewise down here, the magnetic field is going to be mu naught Ni upon 2. Right? So that's going to be for both of them. We can sum the two of these up for the total solenoid. So B total is equal to mu naught Ni upon 2 plus mu naught Ni upon 2. And what we ultimately get is we get mu naught Ni is what we get for the total magnetic field for these two infinite sheets of charge. Now there's another thing we can look at. We can look at the direction of the magnetic field, which way it's going to flow. So we're going to use our right hand rule. Our fingers are going to represent the current, and in this case the current is coming out at you, just as the dots represent. And the crosses or the X's mean that it's going to be going away from you, and our thumb is going to point in the direction which it flows. So if we do the right hand rule, we see that our thumb is pointing this way. So this is going to be our north field, this is going to be the south field, and our magnetic field is going to flow in that direction. Likewise, it will flow in that direction. As such. All right? And so we can represent the magnetic field of a solenoid as mu naught Ni by simply think of it as in terms of two infinite sheets of charge. All right? And remembering that this lowercase n is going to be the number of turns, so this would be per length. So this would be 1 turn, 2 turns, 3 turns, and 4 turns. So our infinite sheet of charge only has 4 turns. So if you happen to have any questions on this, please let me know.